Hello and welcome back to Get Kafka-Nated, the show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people who make it all happen. I'm Hugh, your host, and I'm excited to be back with you for another conversation about the technologies that are reshaping how we think about streaming data. As always, we've got a coffee on us for our live audience. You'll find the link to claim your voucher in the chat. Quick reminder, it's currently available in Europe and North America, but we're working hard to expand this globally for future episodes. Today we're diving into Apache Iceberg and its increasingly important role in streaming data architectures. I'm delighted to welcome Alex Merced, Head of Developer Relations at Dremio and co-author of Apache Iceberg, the Definitive Guide. Welcome to the show, Alex.
Thanks for having me, Hugh. I'm excited to be here.
Awesome. Well, let's get right into it. So for our listeners at home who might not be familiar with Apache Iceberg and what it is, why should they know what Apache Iceberg is, what is Apache Iceberg, and why should Kafka users care about it?
Got it. Okay, this is one of my favorite topics. I wake up and I go to sleep thinking about data lakehouses and Apache Iceberg. So let's just talk about the why. So it really comes down to the fundamental problem is as data scale grows, as organizations grow, basically how you structure your data platforms grows. So one pattern you see a lot is that different departments will each have their own data platform. So you'll have one department that's using Redshift, another department that's using Snowflake, and so forth. So what ends up being the result? The result is you have to ETL data from one department to another. So not only are you doing that original ETL of the data or loading of the data into the system, but then you're loading data across systems, which also increases the time it takes to make the data available for your AI and BI use cases. It also costs more and also just increases the chances of something going wrong and having inconsistent and incorrect data. So overall, not an ideal situation. But the problem is, if you try to centralize everything on a single data platform, it gets really political because everyone has their preferred tool. We're trained with that tool. They love that tool. So how can we sort of cross those T's and dot those I's where people can use a tool that they want without having to replicate the same data over and over again? And this is the beauty of the world of open table formats. So the idea is, how about we just use something you already have as your fundamental sort of data warehouse storage. In this case, the data lake, using your object storages like S3, ADLS, et cetera. You're probably already storing files, usually in the format of like Parquet for analytics, already on there. So how can we make that more like a data warehouse and give it the same functionality of a data warehouse? And then that's where Apache Iceberg comes in. What it is, it's a metadata layer. It's a way of writing metadata around groups of Parquet files. So that way those groups of Parquet files can be understood as a singular table. So that way it's not me saying, hey, Dremio, go talk to this folder of Parquet files. I'm saying, hey, go talk to the sales table, go talk to the orders table. And the Iceberg metadata allows Dremio, Trino, Snowflake to understand what that sales table is, which Parquet files are part of it, which Parquet files may be needed for this particular query, and so forth. And now what happens, now you can have multiple tools. Everyone can use their preferred tools on a singular copy of the data, eliminating all those costs, all that inconsistency, and also just being able to deliver that data faster to your AI and BI use cases because you're not having to replicate the data as much.
Amazing. That's such a good answer. I like that as well, thinking about a technology that's as much as solving like a technical problem is solving like the classic political problem within a company of like, which tool do we prefer to solve this problem, right? Like anything that's unifying different technologies and people is like always a huge win, right?
Agreed.
On that point around like bringing different bits of the architecture together, this is a show called Get Kafka-Nated. There's going to be a lot of Kafka talk today, as well as Iceberg chat, of course. When it comes to Kafka and Iceberg, particularly in your kind of DevRel work, what are the successful patterns you've seen for people streaming streaming data from Kafka into Iceberg?
That's been one of the like early challenges because I would definitely say like Iceberg's original sort of design was definitely very batch oriented. Essentially, we were writing a bunch of Parquet files and the metadata around those Parquet files. And ideally what you want is those Parquet files to be sort of in the ideal sort of shape with ideal co-location of data up front, so that we have to do less optimization of those data files later. So that's much easier in a batch workload where I can have much larger bunches of data, sort them out, and write them into much more optimally sized files. So there's different patterns I've seen. Sometimes people will just use something like a Flink to land that data. Sometimes people use like Kafka-Connect. Basically, a company by the name of Tabular, which was created by the co-creators of Iceberg, they had created a Kafka Connect sync that got contributed to the Iceberg project, and that's something that a lot of people use. And then so those were some of the main patterns. And nowadays, you're starting to see much more sort of vendor-driven streaming sort of tools, which allows for a couple other really nice benefits. Because one of the challenges with using things like Kafka Connect or Flink, one, managing these open source tools, which are great tools, but again, managing them is always a whole lot of fun. But two, when you're streaming into Iceberg and you're making a lot of commits, you run into a problem where you're creating a lot of files. Okay, so you might be streaming. So if I were to just literally stream every time, every second into an Iceberg table, then I'm creating a bunch of Parquet files with a very few amount of records, creating what's called the small file problem. So now when a tool like Dremio wants to go read this table, it's having to open up way many more Parquet files with the actual data, way many more manifest files that actually contain the list of the files, because every time you write to Iceberg, you're creating new manifest files that are listing those new files that just got created. So you end up having this sprawl of data files that have to get read by the engine. So the issue is always like, how do I compact that? Or how do I manage that growth of files? So, basically what I'm seeing with different types of solutions, it's kind of like what you guys are doing over here at Aiven with sort of your new feature, where basically you kind of come up with sort of like an ideal sort of like, how much data do I want to have in my stream before I commit it to Iceberg? And then I think that approach has actually been pretty fruitful as far as making sure that you have decently written files that have a decent amount of data, but still trying to capture data as it comes in. And then as far as like, go for it.
Oh, no, you go.
Okay, final thought on this is just that, like, other things I've seen, and not necessarily in Iceberg, but patterns that probably will be adapted to Iceberg, there's another format called Apache Hoodie, where like that came out of Uber, and their focus was streaming. So like that was the problem they were trying to solve. So their metadata structure is very different. It's broken up a bunch of many more files, so that when you're writing, you don't have as many different processes touching the same file, so that we can split up that work. And what they do is they have a tool that's actually built into the open source project called the Delta Streamer. And what it is, it's this tool that actually, as you stream data into like Hoodie, it's actually like in a parallel process doing things like compaction and rewriting those data files and metadata for that sort of optimization process. One thing I like about, and I think is good about the Iceberg project, is that it doesn't try to solve all problems within the specific project itself. And this has allowed there to be a very robust vendor ecosystem, which I think has actually helped Iceberg become adopted more, because you have many more people who have like a stake in seeing the success of Iceberg. So they make contributions to the Iceberg project, but they also create robust sort of vendor-driven, products around Iceberg to make it easier to ingest into Iceberg, easier to query Iceberg, easier to govern Iceberg tables. And the Iceberg ecosystem is honestly the number one reason to adopt Iceberg over other open table formats.
That's such a great answer. There's like so much to like unpack there, and it covers so much ground. Like I was going to jump in with a follow-up question of like, are there any anti-patterns with like Kafka to Iceberg? But I think you covered that in the sense of like that fire hose of so many small files, which is, I mean, it can be problematic for, distributed database indexes and all kinds of formats, right? But that fire hose of small files being so problematic, and a hard problem to solve. One question I would say then, following on from that, when it comes to compaction for Iceberg, what are the best approaches, particularly around streaming, but in general, like if you do have that fire hose of small files, how do you bring it all together?
Okay, so if you're streaming into Iceberg, one of the things you do want to do is you want to have a well thought through compaction strategy, because data is kind of entering your Iceberg very frequently. So a couple of tips I like to give when it comes to thinking through what the cadence is. One, first off, is looking at how are you partitioning the table? Because like, let's say you're partitioning the table by like hour, then running a compact job every hour is going to be pretty ideal, because then what's going to happen is that when you rewrite that last hour of data, sorry, 1 second. Okay, and then again, for those viewing, I am sort of in a checking out of a hotel, so I apologize for any background noise. But as I was saying, what you would want to do is say, okay, hey, I have hourly ingestion. I want to compact at the end of that hour. So that way that last hour of data is going to be rewritten in the ideal form because there's going to be no additional data for that compaction. This is assuming there's no later upsert. So again, this is assuming like a append-only kind of world. But the question is, how fast does that job get done? If it's a lot of data, even though you're only compacting that last hour's partition, that might still take too long and run into collisions with ingesting the new data in the next hour, depending on sort of how the jobs are set up. So other patterns you can do is that you may not necessarily want to do like the ideal sort of like compaction where you sit there, because what you can do is you can tweak compaction jobs to say only compact files that are above a certain size or below a certain size. So what you may want to do is say, okay, hey, only compact files raise that minimum, so that way you're not necessarily rewriting as many files. So files that are like only the tiniest files get rewritten, and files that are like, they're not as big as you'd want them to be, but they're all right enough, don't get rewritten. So there's less work being done during those jobs, so they're quicker. So you're still optimizing the table, but you're doing it incrementally, and then you can do a much more long-running job during, off periods where where ingestion isn't going on. Things like that.
That makes sense. Oh, also, yeah, the classic compaction problem of like, how do I get the best query performance without overly impacting my write performance, right?
Yes. But yeah, so it's all about trying to tweak those settings, and it's going to be different for every particular streaming pattern because it's going to be dependent, again, ingestion, depending on your partitioning patterns, and then, then it's just experimenting and trying to get those settings to where the job lengths are going to be in tune with sort of the pace of your ingestion.
That makes sense. Another area I can kind of imagine having a lot of issues with streaming data from Kafka directly to Iceberg is around like schema evolution. So obviously schemas change, whether or not that's planned or unplanned as part of streaming. How do lakehouse formats and table formats like Iceberg cope with schema evolution?
I mean, in the Kafka Connect connector, what they did is that if it detected a column that wasn't there before, it would add the column. It wouldn't necessarily drop a column. So the idea is like, okay, then there's just a null value in the old column if that column is not there's no new records being ingested in there, but this new column now is going to receive records going forward. And the cool thing about a format like these open table formats is they do enable that schema evolution. Back in the day before, when it was just Parquet files, that wasn't possible. So basically you would have to go back and rewrite all the previous Parquet files before you even started the job. Now, you could just say, hey, the new Parquet files are written with the new schema, but the actual current schema is in the metadata. So now a tool like Dremio that might be running a query against those tables, it can then sit there and superimpose that schema across the whole data set and be able to sit there and like say, oh, okay, well, there's this column here for these Parquet files that don't have that column, but it's null. Or I think in the future they're going to add I'm not sure if it came out in V3 or something that might be proposed for V4, is adding like a default value for those situations.
Got it. That makes sense. So this is something that I'll admit, the first time I've touched Iceberg was at the London PyData conference like a couple of months back. Super cool workshop there on like messing around with Iceberg and using neutrino and stuff. And I was like, oh, this is really neat. Like I'm looking forward to playing around with Iceberg more. But one of the things that was kind of blowing my mind about Iceberg then was time travel, right? Like this idea of, you update your metadata, it changed the Parquet files you're pointing at, and then suddenly you're looking at data from like a week ago or 2 weeks ago or whatever, right? Like, is that so? Could you help me out here as an Iceberg beginner, right? Like, let's talk a little bit about time travel. Like, why is time travel a thing in Iceberg? Yes, why is it possible, and why is it useful?
Got it. Okay, so first, why is it possible? The cool thing about it is that the way open table formats work is that everything's immutable. So in this case, you're never editing sort of the old data files. You're writing new ones to replace the old ones. So you have what's called snapshot isolation. So the metadata will say, okay, hey, we just updated the table. So there's a new snapshot, okay, that has a snapshot ID, and then here's the list of files that are in that snapshot. So which Parquet files belong to which version of the table are in the metadata. So now what I can do is that when I say, hey, I want to query this older snapshot, I can specify that snapshot ID, and then basically it can pull up the right list of the right Parquet files for that version of the table. Okay.
Super cool.
And yes. But to add to that, Okay, for that version of the table, the benefit of having time travel is one, you can do all sorts of cool auditing work, like being able to sit there and say, hey, here's how the table was a month ago. We know this is some sort of problem. What's different between the version a month ago versus the version today? Now, the catch is you're still retaining all those data files. So in this case, if you're retaining every snapshot forever and every data file that ever got created for all these snapshots, a 1 GB file, a 1 GB table could become a 10 terabyte table with all the files that have been sort of saved for it. So there is good hygiene when it comes to this. It's called snapshot expiration. So you do once in a while want to sit there and say, hey, expire these particular snapshots or expire all snapshots older than a certain date. And what that'll do is that the process will determine, okay, hey, these are the files, these are the snapshots that are valid after this event, and these are the files associated with those snapshots. Here's the old list of files. Which files are not on both lists? Delete those files. And then basically it'll clean up your space, and now you're not storing so much data. And another reason you want to do that is not just so you don't have that cost of storage, but also the more snapshots you have, you also have the metadata for all those snapshots that can also extend the length of doing the metadata processing. So it's a great feature to have, but you want to have a sort of clear data retention policies if you want to take advantage of that feature.
That makes sense. And I think it's probably a familiar feeling for like Kafka practitioners with the whole like, oh, how long am I retaining messages and stuff like that,
Yes.
right? It's that like, how many days do I want to deal with an issue when it arises versus how much do I want to be paying for my data retention?
100%.
But yeah, such a cool feature, and definitely one where when I saw it for the first time, I was like, whoa, you can do that? That's crazy. So much easier than trying to remember what offset you want to be at.
Yeah, it's really cool. That's the beauty of it. And then to be fair, like that's a feature in all the three main formats because they all do that same snapshot isolation. So they all have schema evolution. They all have time travel. The things that are like sort of unique to Iceberg are two particular features: partition evolution, where you can actually change how the table is partitioned. That's completely unique to Iceberg. And another feature called hidden partition that just makes partitioning easier. I'll leave it at that.
Very cool. We were talking about this a little bit before the show. So over at Aiven, we broke the news about Iceberg topics this week. So this is our kind of our experiment in open source. I hesitate to call it a feature yet because we're still figuring a lot of stuff out and we want to get people's thoughts on it. But essentially, we're making a kind of Kafka topic that's directly queryable as an Iceberg table without using a connector. So I know we were just talking about this, and this is like brand new as of yesterday, so like hot off the presses. What's your take on the idea of Kafka topics that are queryable from Iceberg without a connector?
I think having the data queryable as Iceberg is generally going to be a better experience from the querying point of view. The reason being is you do have all this metadata that's going to allow a query engine like a Dremio, like a Trino, to be able to query that data more intelligently. Because now I'm not loading all the data. I can use this metadata to determine sort of which portions of that data I want to more intelligently scan. Of course, there's always the challenges of trying to like keep those two things, like the Kafka topic and the Iceberg table, in sync as closely as possible. But I mean, I keep seeing efforts like this one and others that keep getting closer and closer to really kind of getting a really low latency there. So I think streaming into Iceberg is becoming more and more practical every day, and there's a lot of really good efforts in making that practical. But I think it's worth doing because one, you're going to get better performance when on the actual query of the table, and then again, people can then bring their own preferred tool. So now, do they have to go query the table with X tool? No, they literally any tool that supports Iceberg can now query that stream.
More broadly, when it comes to this like tighter coupling of streaming and the lakehouse and of Iceberg, do you see any like changes in the ecosystem or any areas where this is maybe replacing sort of maybe traditional connectors or ETL or complementing them?
I just think like the lines are blurring. Like basically it's becoming sort of, there's data and then your lakehouse. Before it was like, okay, I have data and then I have all these different systems that do different things for different reasons. So now it's really get data, get it into your lakehouse, and then for your highest, like, or where you need the lowest of lowest latency, then you can build something that kind of directly queries the stream. And then that's sort of like the paradigm that I think things are getting more and more to. And then also get basically the value of the lakehouse and the reality of, it's hard to get perfect latency when you're writing to the data lake. I think it's in a good way forcing people to ask the question, sort of like, what are their actual requirements, and having conversations like, hey, do I really need 100 millisecond latency? Am I fine with 5 seconds? Am I fine with 10 seconds? What is it that actually helps me answer the questions? And that allows them to design better ingestion jobs that are also more affordable, more just a lower burden, easier to maintain. So overall, it's like some of what people might think was rough edges, honestly, is forcing people to kind of think through better practices. And I think that's a good thing. And then people are working on making those edges smoother, as some of these features we've just talked about a second ago. And that's also, it's a good world. It's a good world to be in right now.
I like that a lot as a way of thinking about it, particularly coming at it from the perspective of like having been a data engineer, and you're like, do we need these SLAs or do we just want to be real time, right? Like an engineering challenge being an opportunity to like consider the problem more, as opposed to like, well, we need a bigger hammer for this, right? Like,
100%.
I like that as a way of thinking. Talking about the kind of evolution of streaming and lakehouse and things like that. Obviously, you're deeply involved in the Iceberg community. I mean, you've literally, writing the book on Iceberg is always a good start, right? How do you see the landscape evolving right now with all of these different solutions, like Delta Lake, Hoodie, now things like the direct Kafka integrations, even with Iceberg being this great equalizer of like working with all these different technologies, what drives people to choose something like Delta Lake or Hoodie or Iceberg over one another?
Yeah, I mean, I would say like all three formats are going to be around. They're not like going anywhere. But I do think we've gotten to a point where Iceberg is essentially, I would think of as the default. So essentially, like the way I would think about it is I want to land my data on Iceberg unless there's a good reason for me to land my data in like Delta or Hoodie. And generally, like the reasons I would think are, one, like Hoodie would be because of the latency issue. Like if you really are trying to build like that real-time lakehouse, at least at this point, Hoodie has one of the better stories there, just out of the box. But again, everyone's working on making that story better with Iceberg, so that story has gotten better with Iceberg. So how much would that be the thing? We'll see in the years to come. And then Delta Lake, well, Delta Lake still has, when it comes to the Databricks ecosystem, is going to have a much more first-class native integration. So if you're all in on Databricks, it's going to be hard to avoid using Delta Lake to some extent. Even though they have expanded their Iceberg support, it's always going to be a Delta Lake first platform. But when you go through like the rest of the ecosystem, most other tools, like for example, like Dremio has been all in, was probably come to think of it, I think the first commercial vendor to really be all in on Iceberg. Basically, you're going to find much more first-class Iceberg support across the ecosystem, making it again more compelling for it to be sort of the default. You start with Iceberg, and then you deviate when there's a reason to.
That makes a lot of sense. That last line in particular, that like start with Iceberg and then deviate when you need a reason to, is reminding me so much of kind of where we've ended up with Postgres, where it's like, all of these different database technologies out there, they're all out there, they're all great. I've spent some time working on the Apache Druid project, for example, and you're like, oh, here's this like more specialized OLAP columnar database, whatever. But ultimately, 9 times in 10, you're like, well, if you start with Postgres, you're probably going to be fine, right? Like if you have specific design or engineering constraints down the line or challenges, then maybe branching out is going to be useful, but Postgres probably covers most of your bases. And I feel like watching Iceberg for the last 18 months, 2 years or whatever, it feels like it's very much headed in that direction, where it's becoming the kind of default, at least in the open source space, sort of the default option.
And I think there's a good reason for that. One is, there's a couple different reasons. One, it puts everything, I think all the main features you would want are in the format in itself. And the reason for that is because it's an Apache project. It's something that was basically like how it evolves is really community driven. There's no like sort of one player that says, hey, this is going to be the future of this project. And because of that, it's basically, it's good or great for most use cases. Okay, it doesn't necessarily specialize and try to do one amazingly, versus like Hoodie started out at Uber, was trying to solve that streaming problem. So it's really, really good and really specialized for that, and has since broadened but that's where it's kind of like started, and it kind of really where it specializes. And then Delta Lake, for a long time, the features were kind of half there, half in the Databricks platform. So you can have a great experience with Delta Lake, but you need to be using the Databricks platform to really get some of its sort of key, sort of really nice marquee features. Using just the OSS Delta Lake alone, you lose a few things. Well, with Iceberg, you kind of get all the Iceberg stuff no matter what you're using, and that makes it just sort of like a better sort of general, like, okay, I know I can do things if I'm using this, regardless of what tools I'm using.
That's super cool, and it makes a lot of sense, right? I think I'm sure you've had a similar experience, but as a dev role, that sense of like people are like, well, I want something that's open so I can build with it, I can talk to people about it, I can find content. Like the accessibility of a tool is so much of the battle, as opposed to like necessarily even what features it has. Obviously, we're talking a little bit here about how we kind of got to where we are right now with Iceberg. Looking ahead, are there any features coming in the open source space on Iceberg that are really exciting? Anything on the roadmap that you're looking forward to?
Oh, okay. So far as like specifically the Iceberg project, so first I'll talk about Iceberg specifically and things around Iceberg. But as far as the Iceberg project goes, it just approved the v3 spec, which introduces some new data types like geospatial, of the variant data types for like semi-structured data, and a couple other data types. And so that support, you should start seeing more support for that. Like right now, v2 tables, so for the v2 of the spec, are still going to be the default. So generally, if you're writing Iceberg tables, they're going to be supporting v2 features, which means not variant, not geospatial types yet, but probably 6 months. So I would imagine like around December or January, you're going to see most tools starting to release their v3 support, and probably like around mid next year, v3 can then become sort of the default what you write to when you write to Iceberg, and that'll introduce a lot of really nice quality of life, cool things, but a better way of handling deletes that should make doing like upserts, which will definitely help the streaming story. And that's definitely, and just to give credit where credit's due, like this process, this approach of deletion vectors was something that was actually originally created out of the Delta Lake project. But then there's also v4. So people are already making the proposal for v4, which introduces all sorts of, well, nothing's like solid yet, but you're starting to see things like, relative paths, which has been sort of a hang up with Iceberg, where basically it has absolute paths in the metadata, which enables a lot of really cool features. But then it also makes it hard for, like, if you wanted to zip up a table and folder and put it in a zip file and send it to somebody over email, you can't do that. I mean, at the end of the day, ideally, you don't want people doing that. You don't want people making a bunch of copies of the data set. So I think of that as a feature more than a bug. But some people want to do that, instead of just sending over access to a catalog. But that's something that's being worked on. A bunch of other new data types. Some changes to sort of like to make smaller. Some changes to how the metadata structure can be, so that way you can, for very small updates to the table, you can have much smaller amount of new metadata that's created per snapshot. So v4 is going to be pretty exciting, but again, that's probably like 2 years out. Like we just got done approving v3, so then you have like 2 years of people making proposals and then working out those proposals and seeing which ones make it through. But it's exciting to watch. The other big thing I think is interesting is that we're now in a world of the catalog wars, because once you actually have lakehouse tables, you need to track those tables. Because again, if I connect Trino or Dremio, it doesn't just magically know that these tables exist. That's what the role of the catalog is. It says, hey, I have all these tables that exist, and here's where you can find their metadata. But on top of, it's not just listing those tables, but also having all those access control rules. Because I can create access control rules in an engine, but I don't have to recreate those rules in every engine. I would like to have one place where I can define who has access to these tables and what level of access they have. And that's the catalog space. So right now you're seeing the sort of big competition between sort of, in the open source space is Apache Polaris, and I'll come back to Apache Polaris in a moment, but you also have AWS Glue, probably like the longest standing one of the bunch. Databricks has a Unity catalog. Again, very similar story to like Delta Lake, where you have like the open source version and then you have sort of the platform version, and there is some like feature differentiation that sometimes can be a little tricky to pick up from the documentation, but something to be aware of. But what's going to be really important about this particular battle, which when you take a look at what happened with Iceberg, is the ecosystem is what led it won eventually. The idea is that, hey, I could use all these different tools with it, and not just use them, but get really first-class support for this format in those tools. You're starting to see that already with Polaris. Like Dremio and Snowflake, these are the two companies that partnered up to create Polaris in the first place. They already have a commercial offering for Polaris, but I know of at least like 3 or 4 other companies that are building Polaris into their product or using Polaris in some sort of way. And I think that's just going to accelerate. So you're going to start seeing an ecosystem where the catalog that most sort of like the default catalog that people are going to build into their products is going to be this Apache Polaris project, because you can just pick it off the shelf and add it to your product. And you have support from some big names that are working on the project. So I think the ecosystem side of things. So right now, Polaris may not necessarily be the most feature rich yet, but neither was Iceberg at a point. Delta was more feature rich than Iceberg, and that flipped because of that ecosystem pivot. And I'm starting to see that same pattern happen with Polaris. And the reason why that's important is because once there's a standard catalog, then you can go beyond Iceberg. Now there can be one catalog that defines not how we handle Iceberg tables, but how do we handle other formats? How do we handle unstructured data? And have one catalog that can track all those things and govern all those things. The problem right now is AWS Glue does it, but they do it their way. Polaris is starting to do that. They came out with like the general tables feature, and there's other proposals for a feature called volumes for unstructured data. So they're coming up with a way. Unity Catalog has their way of doing this stuff. And the problem is every tool, like the Iceberg piece of it, pretty straightforward. There's a uniform interface called the REST catalog interface that allows you to talk to any catalog pretty easily. But for everything outside of Iceberg, there's no standard. So one of these catalogs has to win and be the one who establishes that standard. And based on history, the open source community-oriented project will win out setting the standard.
Super cool. Yeah, I think that's even in the short life of this show, that's the story we've seen repeat itself so many times. Is it's like when people come together and they build stuff in the open and they like work to collaborate, then it can so quickly just become like, well, that's the way we do things, you know. And it's kind of beautiful to see sometimes.
Yep. And on one little side note, one self-serving little side note, my second book is actually Apache Polaris, the definitive guide, which should be coming out in a few months.
Amazing. Well, we'll have to share that then when it comes out.
Yep, you can already get an early release copy over there at Dremio.com.
Well, we will all be heading over there afterwards. Exciting stuff.
So.
Well, this has been fantastic, and I'm looking forward to the book now as well. For listeners who want to dive deeper into Iceberg, I know you've got extensive resources, and don't just say your book. Where should they go to find out more about Iceberg? Although you can say your book.
Yeah. Well, I mean, yes, everyone. Well, first off, the Iceberg documentation is great, and it's gotten a lot better over the years. If you go to Dremio.com, like the Dremio.com blog, that's where generally most of my Iceberg content is outside of the book is. And there's lots of tutorials where I have very simple environments that you can spin up using just some Docker containers. We'll have like Dremio and a catalog, and you can write some Iceberg tables and get hands-on. So if you go to Dremio.com/blog, and I also have tutorials with like Spark and Flink. So lots of stuff to get hands-on with Iceberg. Also, if you go you can find the early release copy of both books over there at Dremio.com. And if you have trouble finding where to find the books, just head over to alexmerced.com, and I do have a direct link to both of those pages right there for easy finding. And then aside from that, there's a Medium. There's like people posting blogs on Medium all day, every day. I post a lot of blogs on Medium, so if you don't follow me on Medium or Substack, do so. I write a lot of content every week, so you don't want to. To quote Aerosmith, you don't want to miss a thing. You know, why not? Let's end it with some humor. But yeah, I mean, honestly, there's a lot of content right now on Iceberg, but most of the content I've written is either going to be on Dremio.com or findable on Medium.
Awesome. Great stuff. And thanks again for coming on the show, Alex. I've really enjoyed this.
No problem. Anytime.
Awesome. And thank you to everyone who joined us live for another episode of Get Kafka-Nated. Next time, we'll be joined by Satoshi Tagano from Uber for the story of one of the biggest features to be added to Kafka in recent years. Oh my God, I'm tripping up over myself today. One of the biggest features to be added to Kafka in recent years, tiered storage. If you've got topics you'd like us to explore, want to be a guest on the show, or have feedback on today's episode, please reach out on LinkedIn. We're always looking for new voices and perspectives from the Kafka community. Thanks for listening.